Hi everyone, it's me Phil. I just wanted to use this video as an opportunity to show you all something that I worked on back in July and kind of explain the code. So here is an application called Wii Tic-Tac-Toe. I'm using Dolphin Emulator for this. It does run on the actual Wii. So if we press A to start the game, we are on this game board. The cursor follows, or the picture follows your cursor position. You can press A to place a circle, and then AI will place an X, and you can just play tic-tac-toe. It is impossible to win, to my knowledge. I don't think there's a way you can win. Maybe. I'll show you what it looks like when the computer wins. But there is a player wins message. I haven't seen it, and I'll show you guys why in a second. So, all right, So let's look at the code. So as you can see, I'm using grlib for graphics rendering. I'm using, this is programmed in C++. Well, okay, so it's almost all C with just elements of C++. I believe grlib is actually C++ library. Similarly, we use and WPAD are both C libraries, which I'm using for taking input from the Wii remotes. So contb.h, this is the continuum font that I downloaded from the internet and converted into a font using an object to binary program that downloaded from the internet, compiled using CMake. And I used player1 point.h, so that is an image file that I just downloaded from online, just homebrew player cursors. That I then also ran through an object to binary program to create that image so I can put it into my program. So let me just go through the code and explain to you what all of it does. So here we have two structures defined. So the first one, this is the board, the actual board itself, which is defined as an empty array of 3x3. It creates the 3x3 array you see for the board. And this is for the cursor, this structure, the second structure. It keeps track of the IR positioning of where your cursor is pointed, so it knows where to put your input, and so it knows where to put the pointer image. These predefined colors are just for the background and for the font. So let me go through this. I have some notes. So initialize board, it sets all spaces on the board to be empty. Draw board. So this actually renders the board on the screen. So it checks each cell to check whether it should display an X or an O, depending on the board state, and it draws the IR pointer where the Wii remote points. So this is just debug code that I had to check to see where the cursor was pointing and for aligning with the image of the pointer. So these are all grlib commands. The offset X and Y is the offset of the cursor relative to where the player is pointing the Wii remote. So basically this function is checking every cell. It's checking the state of the board, and if there should be an X there, it's placing an X, and if there should be an O, it's drawing an O. And these are also for IR coordinates. So this is trying to center the texture of the pointer to the player's IR position. I do this again later on in the main method, and I'll show you guys how I did that. That was kind of tricky. It took me a long time to figure that out. So let's move on. So we have game logic here, right? So full, this method checks if the board is full, which would indicate a draw. Check win. So this checks for any winning condition. So it's checking for 3 X's or O's in a row, column, or diagonally. Evaluate. So this is actually a part of the minimax function that I'm using for the AI. So what this does is it's returning a score based on the state of the board. So it either favors the computer or the player. And I'll get more into that in a second with the minimax function. So minimax is a recursive AI function. So it allows the computer to play optimally. It chooses the move that maximizes its chances of winning. And it also, I should have written my notes that it minimizes the chance of the player winning. Let me try. I have more notes. I'm looking. So basically, the algorithm is exploring all possible moves recursively. So for each possible move, it considers each potential response by the component, then every response the AI can make, and it builds a tree of possible game states. So this AI is actually useful in chess and checkers. Once the AI's turn, the algorithm will choose the move that leads to the highest score. And once the opponent's turn, the algorithm will assume the opponent will choose the move that minimizes the AI's chance of winning. So basically, it's choosing whatever will return that -10. And the recursion will stop when the tree eventually reaches a terminal state, so a win, loss, or draw, um, or at a certain depth here. Um, so basically, it generates each move and evaluates each move. So evaluate here, see how it returns points. These are points that the AI is using to check whether or not it's maximizing or minimizing scores. So then it recursively was between maximizing the AI and minimizing the opponent until the terminal state is reached, and then it will return the score when the base case, so the terminal condition, is reached. And then it will choose the move with the highest score. So let me go back to my notes now that I've explained that. Okay, so here are some gameplay functions. So best move. This is what's used to determine the best move for the computer, and this uses the minimax algorithm. Title screen. So this displays the title screen and waits for the player to press the A button to start. You see right here, and all these grlib stuff is just for displaying. Because before I had it working, but it was on like a kind of command prompt kind of thing. It was like just a black screen, like a basic grid, and that was cool. But it took a whole like 10 minutes. This took a lot longer than 10 minutes. I did learn a lot doing this though. It was worth doing. A lot of fun. So this is the game over screen. It displays the result of the game, so the win, loss, or a draw, and it will prompt the player to either restart or return to the title screen. It's looking for the A or B button to break the function. And finally, here's the main function. So the game starts by initializing grlib for rendering. It sets up the WPAD, which is the Wii remote, and it loads the font and player texture before taking you to the title screen. And the game enters a loop where it alternates between the player's turn and the computer's turn. Here's the main game loop. Sorry about that. And it uses the IR for input. So this is what I talked about earlier when we were adjusting the IR coordinates. So basically, this is adjusting the exact position of the pointer for the program, the image of the pointer, how it aligns with where the player is pointing. So it took a lot of adjustment for this formula to have it like just work in a way that didn't feel uncomfortable, because for a long time it's doing it again. That's okay. Hey, happens. But it was like this, but like every time. So I don't know if you can see where my cursor is right now, but the pointer image is like far off. It does this sometimes when I exit when I alt tab out of Dolphin and then go back into it. It just does that. But this is what it was like forever, instead of having the pointer neatly under the cursor. Yeah. So adjusting this here fixed it. So then I call that drawboard method I went over earlier, where we initialize the game. Well, actually, we initialize the board up here, where we draw the game board using grlib, and it exits if you press the home button. And then this is checking to see if it's the player's turn. I'm looking on the player's turn. They can use the Wii remote's A button to select the cell, and the AI will play immediately after using its calculated best move. So then, if the player or computer wins, the board is full, or the board is full, the game will transition to the game over screen. Try a game over. And then the game will end when the home button is pressed, so it frees resources and exits gracefully. That part does exit, just not very gracefully. If you close Dolphin, if you try to close the window, it will not shut down. It's very stubborn. But yeah, so I learned a couple things with this program. I learned how to use grlib, which was interesting. At least just the basics of it. I learned what an Object-to-C program was. This is my first time programming in C++, like in terms of like real programming, making something that actually functions rather than some kind of algorithm for a class. This is the first time I've done anything with the Wii. This was my first like video game project like just ever, which I had a lot of fun making it. It was hard. I mean, it easily took over 30 hours for me. I'm sure for a lot of people it would be a lot quicker than that, but I'm kind of new to C and C++. It's not what's mainly taught my university. It's really Java. Um, but I had a lot of fun doing this, and if I can figure out how to get CMake to work again, I will definitely be back to making little Wii games like this. So I'll just show you playing it one more time. Let me restart. The cursor works again. So the title screen, we press A. I can press A. See the issue. The only like issue in terms of gameplay is that the AI always wins or draws. I just can't win. With that said, thank you for watching my video on Wii Tic-Tac-Toe. I will have the code uploaded to GitHub. I think I already have it uploaded to GitHub, but if I don't, I will 100% put it on GitHub, and I will link it in the description along with the pointer and the font I used. So if you want to make this up by yourself, you can. So thank you.